How to test a drag race timing system. Many people speculate on how a drag race timing system works. They also want them tested so that they can promote the accuracy. The problem with testing a system, unless you are from a governmental bureau of weights and measures, is that the device that you use to measure the accuracy will always be in question. One way to measure a system for accuracy is to measure the system against itself. This method makes sure that all inaccuracies are based on the operation of the system and not dependent on the device that measured the inaccuracy. In order to perform this test, you must find the location of the main junction box or junction panel. At that point, jumper all left inputs to right inputs from the track sensors. All start line and down track sensor inputs were jumpered together. Pre-stage left to pre-stage right. Stage left to stage right. 60 foot left to 60 foot right. 330 foot left to 330 foot right. 660 foot left to 660 foot right. 1,000 foot left to 1,000 foot right. 1320 foot left to 1320 foot right. And final speed left to final speed right. Most importantly, you must connect only one lane of sensors on the track. If you connect every sensor in the left lane, then you must make sure that every sensor in the right lane is disconnected. The testing at this point is very simple. Line a vehicle up in one of the lanes. You will note that both left and right pre-stage lights and both left and right stage lights will be illuminated when the vehicle is final staged and ready to race. When you start the system, the tree will sequence, and as the vehicle moves down the track, the result will appear on the screen. At the end of the race, a data log will print, and you can analyze the results. If you look at the data log printout, you will note the variation in the margin of victory numbers. This printout shows the left lane always winning by a margin of victory of 0.0002 seconds to 0.0009 seconds, even though the signals are reaching the left and right lane finish inputs at exactly the same time. Why do we need accuracy past 3 places? Why don't we just find out which vehicle finished first and let it be? The reason that a timing system requires at least 5 places of accuracy is due to the speed records that can occur. The chart on the screen shows how many miles per hour is calculated over 66-foot speed trap on a standard asphalt drag strip. Convert the 66 feet into miles by dividing 66 by 5,280 feet. 66 feet converts to 0.0125 miles. By multiplying 0.0125 miles by 3,600 seconds, we end up with a constant of 45 miles per hour if you take exactly 1 second to go 66 feet. The chart shows various miles per hour as the time gets quicker. You note that the time is reduced in half and the miles per hour doubles. The problem becomes very apparent at 300 miles per hour, and as you can see, the 3-place accuracy at best can only yield a 2 mile per hour resolution. Most sanctioned bodies want a resolution of 2 places at 300 miles per hour. The 3 examples of 300 miles per hour shows the mile per hour variance of 0.02 miles per hour at a 0.00001 second resolution of time. Now take a look at the time distance accuracy chart. 3-place resolution can be off a considerable distance, which only gets worse as speed is increased. 5-place accuracy clearly is superior for drag race timing system and is 100 times better than 3-place accuracy. This is clearly the accuracy all races and sanctioning bodies should strive to achieve. The infrared sensors are also a major concern, but that is another topic for another time.